Example 1, we're going to simplify 0.0003 times 10 to the negative 6th times 4,000 times 0.006 times 10 to the 15th over, or times 2,000 times 10 to the 4th. So, first off, I want each one of these numbers to be in good scientific notation structure. So, 0.0003 is too small, it's less than 1. We always want the number here, the abscissa, to be between 1 and 10. So I'm going to move the decimal point 1, 2, 3, 4 spaces to the right to make 3. What I have to ask myself about this number, how I'm going to modify that number based on how I've modified this number is, did I make this number bigger or smaller? So what did I do?
Bigger.
I made that bigger by 4 decimal places, right?
Yep.
So I have to make this smaller by 4. Negative 6 minus 4 is equal to negative 10. As always with algebra, pay attention to detail until you can do it correctly without paying attention to detail. Okay? Most people do this wrong. We'll put a negative 2 instead of negative 10. They think minus 4, they see a 6. 6 minus 4 is 2, and they make it negative. But again, it's negative 6 to begin with. We're subtracting 4 because we're making it 4 smaller. Both negatives add to make negative 10. Next number, we have 4,000. So I'm going to make it 4 times 10. All right? 4,000's decimal point to begin with was right here. I moved it 3 spaces, making it bigger or smaller? Smaller. So I have to make this 3 bigger. It was 0 to begin with. If there's no 10 to a power to begin with, it's a 10 to the 0 power. So 3 bigger than 0 is positive 3. On the bottom, we have 0.006 times 10 to the 15th. I'm going to make it 6 times 10. All right, so 1, 2, 3 spaces. Bigger or smaller? Bigger. So I have to make that 3 smaller. 15 minus 3 is equal to 12. And finally, this last one, 2,000 times 10 to the 4th. I'm going to make it 2 times 10. All right, 2,000 became 2, 3 decimal places. Smaller, so this is 3 bigger. 4 plus 3 is 7. So there's always a complementary deal with that. Whatever I do to the abscissa, I do the opposite to the power of 10. And the number of decimal places that's moved is what I'm affecting the power of 10 by. All right, this problem here is equivalent to the original problem, but it's much easier. Once we get the problem in this format, the next job is to get the top answer as simple as possible. 3 times 4 is 12. And 10 times 10 we multiply by adding the powers of 10. So negative 10 plus 3 is negative 7. Alright, so the abscissas I just multiplied. 3 times 4 is the same product that shows up on flashcards back in 2nd grade, right? Or 3rd, whatever grade it is when you multiplication flashcard. 3 times 4 equals 12 because it does. Powers of 10, we're adding powers. Negative 10 plus 3, opposite signs subtract. 10 is bigger, so it's negative. On the bottom, 6 times 2 is 12. And then we take the powers of 10. 12 plus 7 makes 19. Alright, now those numbers are not in scientific notation. Okay, here's what makes my decision for me whether or not I want to change it to scientific notation. I look at my division problem and ask myself, can I do that? Yep. That's easy, right? Equals 1. Okay, so don't worry about it. Even though it's not official scientific notation here, that's easy. Alright, if it wasn't as easy, maybe I'm going to change it to scientific notation. Alright, but 12 divided by 12 equals 1. I'm dividing, and then for the powers of 10, this is where most of you are going to mess up on this problem. So I recommend this, and I'm telling you right now, out loud in class, I'm going to show you right here on the board what I'm going to do. And if you get me a wrong answer, I'm going to guarantee you what I'm about to write on this board is not going to be anywhere on your paper. You're going to try and do it in your head, and you're going to get the wrong answer. This is what I do. Whatever the top power is, minus whatever the bottom power is. Actually write it on your paper so you can look and see with your eyes what you're doing. The top power, negative 7, minus the bottom power, 19. Those signs are the same, so I add them together. 19 is bigger, so it's negative. Okay? 1 times 10 to the negative 12th is very popular for that one. Because you're thinking subtraction, you see 19 and 7, 19 minus 7 equals 12. And you maybe make it even positive 12, I don't know, somewhere on the sign. But again, for this last step, the division step, always do top minus, actually write it on your paper so you can actually see with your eyes, so you can see should I add or subtract, and then you know the right thing to do.